Okay, this video is going to be a demonstration of how to create a ladder program in RSLogix 500. It assumes that you have the software installed correctly and have gone through the procedure that was demonstrated in a previous video on how to set up RSLinks, how to start the RSLogix emulator, and how to basically create a program and have it set up. So in my example here, I have RSLinks running, I have the emulator running, and I have just opened up RSLogix 500 with a blank program file. So I'm going to start by selecting the menu item File and New, and once again we have to select the processor. Our processor that we're going to use for all labs is going to be the 1747L531 5/03 CPU 8K memory OS 302. We also have to select the emulator driver EMU 500-1 in the bottom left hand corner. When we do that, we start with a blank program file, the standard configuration with the programming window, RSLogix window here in the center, and so I'm basically starting from scratch. One final thing that I have to do that was highlighted in the setup video was I have to configure my I/O. So first card is a 1746 IB8. I double click on that and that fills in. Second card is an OX8, and you should get to know this procedure very well, because you're going to have to do this for each program file that you create. Finally, I click on the NI4, the analog input module card, and now we have our I/O configured based on the standard configuration for the wiring boards in the lab. So I can close this now. The first thing I'm going to do is create a very simple program, and in order to do so, I start here in the ladder programming area. In order to insert a rung, I have to highlight the rung number to the left so that there's a red block there, and I can either click on the icon up here which says start a new rung, or I can hit the insert key on my keyboard. So I'm going to hit the insert key on my keyboard, and a new file is, or a new rung is entered. I can hit the key several times and insert a number of rungs. As you can see, it adds one each time, or if I don't want those, I can just delete them by hitting the delete key. So very simple to insert a ladder rung. So I'm going to start with the simplest of examples. I'm going to have a normally open input, pickup and output. So I'm going to click on the icon up here for the examine on, and I'm going to drag it down here into the ladder file area. Now as I do that, as you can see on the rung that I'm editing, there's red blocks. The red blocks turn green in a location that I can drop them on. If I don't get that green selection, then I can't drop it. So, but when I get to that location it turns green, I can drop it, and now I have an examine on input. I want to enter the address input colon, and it's card slot 1, so it's 1/0. So that's the first physical input on card slot 1 in our rack. I'm going to hit enter, and then there's an address description box that comes in. I'm just going to say input 1, and for a symbol I'm just going to say capitals input 1. Now in our description area here, I can, this is an open text field. I think there's like 5 lines. I can put anything I want here. Word of caution under the symbol. Symbols are unique to each address, so I could not use input 1 the way I've drawn it here, the way I've typed it in here for symbol. I could not use that again. If I tried to do that, it wouldn't let me. So I'm going to click on OK, and it fills that information in the ladder diagram area. So I'm going to take an output and I'm going to drag it here to the location for the output area, and I'm going to drop it on the green slot there. And I'm going to make this output, it's going to be card slot 2, so it's :2/0. So that's my address. It's the first output on card slot 2, which is our output card, and I'm just going to say this is output 1, and I'll type in the symbol output 1. Click on OK, and there's my simple program where I have the first input on card slot 1 energizing the first output on card slot 2. Now, before I can download this to the processor, I have to verify that it is error-free. So I have to verify the project. I go up here to the menu item Edit and select Verify Project, and as you can see at the bottom here it says Verify has completed, no errors found, and the software has filled in the actual card designations for the input card, the IB8, and the output card, the OX8. If there were errors, there would be a window that pops up at the bottom that tells us what the error is, and we have to resolve that before the software would allow us to download to the PLC. The software will not let you download a program with an error. So finally I'm going to go to download the program. I'm going to go up here to menu items COM, and I'm going to say download, and as before it asks for a program file name. I'm just going to say lab1 and click on save, and it's going to say, do you want to proceed with download? Yes, I do. Do I want to go online? Yes, I do. Now at the top I see my file name lab1, and we see the animated icon spinning around. This is a good thing. This is an indication that I'm online with the PLC. It doesn't tell me anything more than that. It doesn't say I'm in run mode, anything else. I'm just online with the PLC. I'm communicating with the virtual PLC in the emulator. If that's not spinning around, you're not talking to the PLC. In the labs, since it's serial connection, this animated icon goes around really slow. Data transfer from the PLC is extremely slow. Since we're working in a virtual world, everything happens very fast, so our communication to our virtual PLC is very quick. So the last thing I want to do to test this thing out is I want to go to run mode. So I go down here to click on run, and of course it says, do I want to change this to mode to run, and I say yes, and now I see highlights, green highlights on the rung elements, and that indicates to me, along with the remote run indication here, that I'm online with the PLC and it's in run mode. So in order to make something happen, if I were in the lab, I would press a push button here for input 0 or input 1, and that would turn on, and it would turn on our output. I'm going to simulate that by right clicking on the input and selecting toggle bit. What that does in the software is it basically simulates me pressing a push button for input 1, and as you can see, that energized output 1. So this simple project does exactly what I want it to do. The first input on card slot 1, when true, energizes the first output on card slot 2. So I'm going to turn this off now by selecting toggle bit, and I'm going to go back to program mode here, and of course it asks, do I want to do this, and I'm going to go back to I'm going to go offline, and it says, do I want to save this? It will always ask you, do you want to save that, because oftentimes data bits and things change state, so it's a good idea to say yes. it will ask for a rev note. You don't have to do this. I'll just say rev 1. You don't really have to do this. It says, do you want to, the data table may change. Do you want to upload those values? I'll say yes. And so now I'm offline. The animated icon is turned off, and I can do additional programming. So I'm going to add a parallel branch here to finish this demonstration. I'm going to add a parallel branch by putting input 1/1 around input 1/0. So either one of those two will energize output 1. So I'm going to take this, I clicked and dragged this icon. This is the branch icon, and as you can see, when I brought that down, again, the boxes where I can drop this thing are highlighted. So when they turn green, I can select that location. And this is not much of a parallel rung, so I need to drag this over. And also, as you can see in my example, the boxes turn green where I can drop the rung to. So I'm going to select this one here. So that makes a simple parallel branch around input 1/0, and I'm going to drop, click and drag another examine on, and I'm going to make this input 1/1, and I'm going to say this is input 2, and I'm going to finish that description. And now I have my simple addition where I have in either of these inputs 1 or 2 will energize output 1. And so I think I'm good, but one last thing, since I have ease here, that means I'm still in edit mode. I need to verify the project, so I'm going to go down here to from edit to verify projects. It says verify has completed, no errors found, so I'm good to go. So now I can download this. I'm going to go to download. It says, do I want to put a rev note? I'll say this is rev 2 and click on OK. It says, do you want to proceed with the download and go online? Yes, I do. So now once again I'm back to the animated icon. The ladder's turning around. I'm still in remote program. I'm going to go to run mode. I'm going to select run, and now I'm in run mode. So either one of these now I should be able to toggle, and now that I've set up input 2 and toggled that bit on, you can see with the highlight that output 1 is on. I can toggle input bit 1 on so that I'm doubly sure that the output is turned on. I can turn off output 2 and we can see that the output still stays on. Only when I turn them both off, since they're in parallel, only when I turn them both off will output 1 be turned off. So that's our simple example. I could add another output to this. I could add parallel branches, but you get the idea. This is basic programming in RSLogix 500 for digital inputs and outputs with series and parallel programming. That concludes this video.